I'd like to welcome to our booth from Intel, Mike Haedrich. He's going to present on the new Intel Xeon Phi. So please have a seat. Join us for his presentation. Mike?
Thank you. We're set to go? Great. Thanks, everybody. Hopefully, get more people in. Come on and sit down. We've got to learn everything you want to know about Xeon Phi. And if I don't know it, that guy right there will know it. So we'll get started here. Is there here we go. So again, my name is Mike Haedrich. I do HPC marketing for Intel. And what we're going to talk about today really is the big announcement we had yesterday on Xeon Phi. So with that announcement, some really great solutions we have now to complement our Xeon solution. So let me jump right into it. So when you look at HPC, you look at high performance computing, you can see there's actually a lot going on, right? You can look at scientific research. We have here industry, competitiveness, national security. All that really requires a lot of compute. And compute is something in HPC, which what we love is that they all want more compute. We can never give them enough. So they continually want to say, how do I get more performance? They keep optimizing their applications. They want to get more and more performance. They want to do more. Now we're looking at big data, right? We're looking at ways of how can we do more. Our smartphones, everything is driving more and more compute power. And what we've done is we've got a product with the Xeon product that has been driving a lot of our performance, a lot of our solutions in HPC. Actually, Xeon is about 80% of what we do today in HPC, and we believe it is the product for the HPC environment. But with applications, as they diversify, as they have different kinds of requirements, we've realized that parallelism is certainly an attribute that we're driving in the industry to ensure that we get as much performance as we can from our solutions. And to complement that, we've introduced the Xeon Phi product. So Xeon Phi complements, it's a coprocessor, and it complements the Xeon product. So how does it complement? What does it do? Why do we believe it's the right solution for your HPC environment, or potentially is the right solution for your environment? It's because with parallelism, what we look at is, what can your application do? Does it need more cores? When you optimize, can it go beyond the Xeon Phi, the Xeon processor? And if it can take advantage of additional parallelism, additional cores, the Xeon Phi is a solution that may be ideal for your environment. When you look at what we've got, a timeline, way back when in the 2004 timeframe, we said, okay, we've got performance. How are we driving performance? We're cranking up the frequency. We're saying, okay, the way to get more performance is crank up the frequency. But in doing that, we also have to drive up the power. So we got to the point where we said, you know what? It's just not economical to keep driving up the power. We've got to find different ways to drive performance. And that's when we really started with parallelism. We said, okay, let's get more cores. More cores is how we're going to get more performance. So way back in 2004 is when we started introducing parallelism. We've been doing parallelism for a very long time. So with parallelism, we said, okay, now Mr. ISV, Mr. Developer, it's not just wait for our processor and get more frequency, you get more performance. It's now you got to optimize, right? We got to start looking at your code and saying, how do I take advantage of more cores? Parallelism, right? We want to take advantage of greater vectors, wider vectors, etc. And you can see the timeline through history here. Teraflop research project back in 2007. That's when we looked at, I think it was 80 cores, when we first introduced an 80-core solution. Larrabee back in 2009. Aubrey Isle was our first mic architecture, which we used for our SDP program. And now we've just introduced the Intel Xeon Phi. So that is not the same as Aubrey Isle. So folks that have used the SDP program, they may say, is this the same product? No, it's not. This is a totally new product. It's based on the 22 nanometer architecture, and it was just launched yesterday. If anybody sat at the during the keynote, enjoyed the keynote for our VP Diane Bryant, she did a great job presenting the value proposition behind this and a lot of the merits that really stand up the Xeon Phi product. So 60 IA cores, 240 threads. So we believe, not only is it the cores, it's the threads, right? We want you to take advantage of the threads that are being offered in the Xeon Phi solution. 8 gigabytes of memory, 512-bit SIMD, if you look at our Xeon product, it's 228-bit SIMD, so twice as many vectors. So it's really built for compute, right? So the idea is, what's the best solution for my environment?
How do you get more threads in cores? Is it doing something like hyper-threading per core?
So it's a great question. I'm going to look over at Nathan here in a minute, but let me give you my rendition, then I'll let Nathan give you the real story. So a lot of people have said, okay, hyper-threading, is this hyper-threading? And you know, I've had an experience in HPC with hyper-threading, and it wasn't real good. Well, we've really made a lot of progress with hyper-threading in Xeon. So now, if you turn on, I'm digressing a little bit. So when you look at Xeon and you sit there and say, okay, I'm going to run, do I want to turn hyper-threading on? Our answer is yes, turn on hyper-threading. Because we believe the worst case, you're not going to get any performance improvement. Before, people said, I got negative performance gain. Well, we believe that has been solved, and now you're looking at worst case, no performance improvement, 2 potential performance gains. Now, with Xeon Phi, we've got 4 threads per core. We believe to get the maximum performance, you want to utilize at least 2 of the threads and potentially 3. And then you got to see where your elbow is, right? Where performance starts to, I'll say, peter out. And then can you take advantage of 4? It depends on your application. Nathan,
It's not hyper-threading, it's a different implementation.
Thank you. He said it in...
He said it well.
Yeah, I was going to say, he said it in 2 words, I said it in 30 words. But so continuing looking on this, standard programming language. And that, to me, is really what sets us apart from the alternative solutions out there, is the standard programming language, right? So if you're implementing Xeon and you're optimizing the Xeon, you are taking advantage of the attributes of Xeon Phi. Are you guaranteed greater performance? No, you're not. You've got to look at your application, look at the needs of your application, because again, we believe 80, 90% of the workloads out there, all they need is Xeon. It's that 10% that can take advantage of Xeon Phi. Teraflop of performance, 2.2x higher memory bandwidth. It's because there's 4 memory channels versus the 2, so a lot more memory bandwidth. I'm just going to go on to the next slide here. This is a great slide because it helps understand the value proposition that we offer with the Xeon Phi. First, if you look at some of the current solutions that are out there in the market, they run restricted code, they perform offload. Restricted code, right? It's not a standard architecture that they run on, right? So if you're running x86, you got to rewrite your code. If you're using x86, what we ask you to do is to optimize your code. And I can't say that enough, optimize your code. And I'll give you an example of why that's so important. I think Diane did a great job yesterday. I don't have her slides in this deck. I wish I did, but she does a great job of that. But with us, or with Xeon Phi, it's really an SMP on a chip. It's a node by itself. You can literally run an application on the Xeon Phi Coprocessor. You can run offload as well, but again, you can run that application. If it fits, if the application is the right size, potentially you can run the entire application on that node. Operates as a compute node, runs a full OS, programmed MPI, run a x86 code. Again, we'll talk more about that, but that's very important. And run offload code. So the opportunities far outweigh what you can do with the alternative solutions. Some of the environments where you can run the Intel Xeon Phi, you can see basically it's really almost across the board on HPC applications. So looking at your code, your application, we're working with over 100 labs as well as ISVs right now. Nathan, is it 100 or so that we're working with to optimize and get as much performance as they can out of the solutions? And I've got some quotes in here that I'll share with you in a minute of what users are saying that have already experimented with the Xeon Phi product line. This is what we announced yesterday. It's a 5110P. It's a passive card, so we have a passive and an active card. Passive, no fan. Active does have a fan integrated. Programmability. We also launched Parallel Studio XE cluster a few months ago. Cluster Studio XE was just new version, I shouldn't say launch, a new version came out for Cluster Studio just last week or 2 weeks ago. Again, Parallel Studio wasn't just, a new version came out. I don't want to say it was just released. So these new versions have optimization to help you support the Xeon and Xeon Phi, to give you better support for Xeon and Xeon Phi. And you can see with the 5110P, ideal for memory bandwidth and memory capacity bound workloads. Right, supports up to 8 gigabytes of memory.
Can you say something about what the compilers are doing for Xeon Phi?
What the compilers are doing?
Yeah, developing toolkit, you said it sort of has some optimizations for Xeon Phi.
So, you want to?
Go on with your presentation, and I'll answer your questions.
Okay, all right, we'll do that. I'm glad you're here, Nathan. A pleasant surprise. So, and we also introduced a 3000 series as well. 3000 series is ideal more for compute-bound workloads. So workloads like Monte Carlo, Black-Scholes, life sciences that really have a lot of compute requirements will see a good performance with the 3000 series. Now this is I want to take a minute on this slide because I think this one's really, really important. I'm going to try to do a little deep dive on this slide. So this is our performance slide, right? And right off the top, I'm going to say, look at the performance gains, 2.7x, Well, let me explain it first. Hold on. So we've got getting Nathan mic'd up. I love it. This is good. So we've got. Let me get over here. We've got we're showing performance with a dual socket Sandy Bridge. Okay, this is the performance we're getting on SGEM with a dual socket Sandy Bridge by itself. This is a single Xeon Phi coprocessor, so it's not utilizing the Xeon. Okay, it's running strictly off the Xeon Phi. So same in each of these instances here. So 85% efficient, very, very high efficient. You look at the alternative solutions; they're not getting that kind of efficiency. And you can see what kind of speed up we're getting, what kind of performance gains. 2.7x, 2.7, 2.3, 2.1 for SGEM, DGEM, Limpact, Stream. And some people scratch their head and go, wait a minute, I'm hearing the alternative solutions are getting 100, 200, 300x performance gains. Well, why are you only getting 2.7, 2.3? What's going on here? Well, what we've done is, in order to get this kind of performance, you have to optimize, right? You have to optimize your program, your code, to take advantage of Xeon Phi. Well, if you're optimizing your code for Xeon Phi, guess what are you really doing? You're optimizing your code for Xeon. So if you didn't optimize your code, your performance might be down here. And if your performance is down here and you didn't optimize, this performance might be down here. So that's why we say optimize your code. That's why we've been saying for the last year and a half, optimize your code for Xeon. Because if you do that, the performance, you're not just going to plug in a Xeon Phi and it's just going to work. You're going to plug in your Xeon Phi, do some additional, you got to say what kernel, what are you using on the Xeon Phi. You have to put some pragmas in there. There's some work you have to do, but it is much, much easier. So again, if you're optimizing, this is recompiled, optimized. You're getting this is the score you're getting, for example, in SGEM. Now you're running it on Xeon Phi, again, because you've optimized, you're seeing significant performance improvement. And alternative solutions are taking a non-optimized single-core solution in some cases and saying, we're getting 300x performance improvement. Well, yeah, you are, but you're not comparing apples to apples. It's really important to compare apples to apples, and that's exactly what we've done here. So in all of these examples, what we've done is we've taken optimized code, recompiled, optimized, and we're seeing what the benefits are with Xeon versus Xeon Phi. So again, we're not seeing the huge gains, but these, I believe, are great. 2.7 or 2.1, you'll see another slide showing some 10x performance gains. That's fantastic. And those I call real performance gains, right? Those are what I think really matters. Here's an example of code that's been optimized on Xeon and what the speed up is with Xeon Phi. For example, here, molecular dynamics, 2.5x. I won't go through each one of these, but Black-Scholes, single precision, we're showing a 10.7x performance improvement. So again, it's optimizing your Xeon. In some cases, you may find out that Xeon Phi, you don't need it. You're getting enough performance gain with Xeon. The Xeon Phi is not necessarily adding additional performance gain. And what's interesting about this chart, we believe what's here in the blue, if you look at this as being HPC and the HPC world, the environment, this is what's going to take advantage of Xeon Phi. This is going to do just fine with Xeon. So again, it's not all of HPC. It's a piece of HPC that can take full advantage of Xeon Phi and see the performance gains.
Can you sort of describe what model of applications fit in that? Is it things that have smaller levels of parallelism?
More parallel. Oh, it's on. So to answer the question, what kind of code can take advantage of Intel Xeon Phi? You're looking for codes that are able to, 70% or so of the code is able to take advantage of the larger number of threads, and 80% of the code is able to take advantage of the larger vectors. And so if you can do both of those things with your code, you're going to benefit from Intel Xeon Phi. Similar kinds of things with other architectures, you have to have similar levels of parallelism inherent in the algorithms that you're using in order to take advantage of GPU accelerators also. Larger vectors.
Why is that important for Phi?
So why are larger vectors important? So the vector unit in the cores for Intel Xeon Phi are 512 bits wide. If you're only using smaller vectors, you're only getting part of the performance you could be getting.
So I think what's important too is you have to take advantage. To get that performance improvement with an accelerator, requirements are very similar, right?
That's right.
So Amdahl's law comes into play, right? If you've got if 80% of your code is serial, you're not going to see huge speed ups by introducing a Xeon Phi, right? For a piece, a kernel may be fantastic, but that's only a small piece of your application. So yeah. So I think this is a great slide as well. I like all the slides, but when you look at game changer for HPC, right? One of the things that we look at is faster time to money, right? You want to get a return on your investment as fast as you can. So what you want to be able to do is be able to, I'll be very simplistic here. You want to be able to plug in a Xeon Phi and just go to work, right? You don't want to have to rewrite all your code and spend 6 to 18 months or however long it takes to rewrite your code to take full advantage of the solution. You want to be able to optimize on Xeon and ramp and get going right away versus complex code porting, basically rewriting your code. It's going to take you a lot longer to get off the runway and get rolling, right? Our objective is, I think what's important here is you're not going from here to 30,000 feet. There is some work to do, but we believe the work involved is significantly less than up here with an alternative solution. I think this is a great quote. We port millions of lines of code in only days in completed accurate runs. Unparalleled productivity. Most of this does not run on a GPU and never will. So again, I think we have a lot more flexibility. There's a lot more things we can do with a coprocessor than you can do with an accelerator. Let's see here. A number of early customer quotes. I'm not going to read these. Really what they talk about is the performance, and you guys please, if you go ahead and read those, but a lot of it's performance, parallelism, the coding. It's about the ability to get up and running quickly, and that's what the previous slide was talking about as well. So maybe I should look at a couple of these, right? Unlike other approaches, I'm looking at the University of Tokyo. Unlike other approaches to an accelerator like GPU, I believe that Mike is the most promising approach. An x86-based server with Mike forms a single architecture for the most powerful next-generation PC cluster. So again, same architecture. It really makes it easier. That's our strategy, right? Let's keep standardization, keep it as simple as possible, and take the solutions that we're offering and get those to market as fast, or get them into your environment as fast as possible and get as much performance as you can as fast as possible. And I believe, broad ecosystem, working with a number of partners. There's a number of providers out there, OEMs, that are now offering Xeon Phi. And if you walk around the floor here, you'll see a lot of Xeon Phi placards. And those are partners that are offering the Xeon Phi, like for example right here, Intel Inside, Xeon Phi. Hopefully every booth in this place has one. I don't think we're quite there yet, but we do have quite a few out there. And we're very excited about, consider we just launched a product. I think we had 7 on the top 500? 7? Okay, good. I don't want to overstate it. So 7, we just launched a product yesterday. We already have 7 on the top 500. So pretty darn excited about that. So everything's looking exciting. We think we've got a great solution, and we think when you look at exascale, Xeon Phi certainly plays in that path to exascale. And when we look at from a roadmap perspective, we've got a great roadmap. It does not interfere with our Xeon roadmap. Our Xeon roadmap continues on the tick-tock model. We continue to offer a very, very robust Xeon roadmap, and to complement that, we have a very robust Xeon Phi roadmap. And one of the leads for Xeon Phi is right here. So much more technical than I am. So if you have, I think this is the last slide, and it is.